Hello everyone, my name is Adrian. Today I'll be talking about improper integrals with discontinuous integrands.
Alright, so an improper integral is an integral that breaks the usual rules for a defined integral in one or two ways. Either the interval is infinite, or the integrand becomes unbounded, which means it blows up somewhere on the interval. We call integrals over infinite intervals type 1, and integrals with an unbounded integrand type 2. Now, usually, to handle type 2 integrals, we turn the problematic endpoint into a limit and see whether the integral settles on a finite number or not. To demonstrate this, I'll work through an example from the textbook, which is the integral from 0 to pi over 2 of secant x dx. Now, when we take a look at the problem, we can see that the integrand is secant x, and by definition, secant x equals to 1 over cosine x. If we look at what happens near the top endpoint, pi over 2, we can say that cosine goes to 0 more precisely. Because of this, we can say that the limit as x approaches pi over 2 from the left of cosine x will equal to 0 from the positive side. Now, because cosine goes into 0, secant, which is 1 over cosine x, if you guys remember, grows without bond. Because the infinite behavior at the endpoint is making the integral improper, we can say that this is a type 2 integral. Therefore, we want to rewrite the integral as a limit where we stop short of the bad point and then let our stopping point approach it. We can rewrite it by saying that the integral from 0 to pi over 2 of secant x dx equals to the limit as t approaches pi over 2 from the left of the integral from 0 to t of secant x dx. Now, we need an antiderivative of secant x. We want to use a known formula because it will give us an expression we can then take limits off. As a result, we get the natural log of the absolute value of secant x plus tangent x plus constant. If we then apply the antiderivative to the defined integral from 0 to t, we get natural log of absolute value of secant x plus tangent x evaluated from 0 to t. Now, because of this, the original improper integral, which was the integral from 0 to pi over 2 of secant x dx, becomes the limit as t approaches pi over 2 from the left of natural log of the absolute value of secant t plus tangent minus natural log of the absolute value of secant of 0 plus tangent of 0. Now, we want to evaluate the easy part at x equals 0. We know that secant of 0 will give us 1, and tangent of 0 will give us 0. Therefore, the natural log of 1 will also give us 0. Now, the limit really just comes down to the behavior of the first term. Because of this, we can now check the inside. As t approaches pi over 2 from the left side, both secant of t and tangent of t go to infinity. So, secant of t plus tangent of t also goes to infinity, which means that the logarithm of that will also go to infinity as well. Now, because this limit is infinite, the improper integral does not settle to a finite number, which means that the integral diverges.